Hello and welcome guys to another session. Today in MindGrid we are talking about algorithmic modeling of the ball on the slope using a software called algodoo. And if I can show you, this is the website where you can download this, algodoo.com. You can download it. It seems to be available freely for Mac, iPad, Windows. So you can download it and install it. It takes a little while to download. The download's fairly slow, but if you just be patient with it, you can download this, and this is what it looks like once it's running. So what I wanted to show was that it's so easy to model whatever you're trying to model. In my case, I wanted to model this slope with some angle, so I could easily add, things like slopes here and this ball, and the slope here is at 30 degrees. So accordingly, this thing has ability to model both friction and gravity, and accordingly it'll produce the effects that you're trying to study in this use case. And you can also set up a nice graph for speed and time. Unfortunately, it doesn't have acceleration versus time or position versus time graphs, which are kind of very useful for somebody who's studying physics at an early stage. But regardless, at least it's providing speed versus time, so that's fairly useful to see. Now, it has lots of different things besides this circle. There's springs and all kinds of things that you can add to build gadgets, and it'll model the gravity and other forces that are acting on your objects, and we'll see in a second how to simulate this. So in my case, I have created this ball. Now the ball has some properties too. So you can see that it has a material with certain density, mass, friction values, restitution, attraction. In fact, I don't even understand some of these things. You can also set up its velocity. So I have set up the initial velocity to be 8.1 meters per second, an angle of 30 degrees, and especially because the angle of this slope is 30 degrees, so I just want the initial velocity to be in parallel to this slope, so I can see how far the ball goes up and what it does, etc. And I created this vertical plane as well, just because I don't want the ball to just roll down the slope and disappear, which it does, which is kind of annoying. So I wanted to put this vertical wall so that it comes down and hits the wall and stops. So that being said, now we are ready to simulate this. We have this set up. One more thing I wanted to show you is that the friction on this material of the slope is set to 0. You can see that I've zeroed out the friction. So there is no friction on this slope. This thing is going to smoothly glide and only be pulled down by force of gravity. And you can see the forces acting on this ball. If you check on this properties of the circle, then you can see that you can turn the forces on and off, and you can look at the various forces that are acting on the ball, right? That's also possible. It's showing velocity right now. I can turn the velocity on and off as well. Somehow it's not doing that. I don't know why, but anyway, you can add things like momentum, and unfortunately it looks like velocity cannot be turned off here. So that being said, you can see that the velocity on this ball is acting upwards at 8.10 meters per second. We could probably make this 8 even if I can. There we go. So it's 8 meters per second initial velocity up at 30 degrees angle. And if we shoot this ball up, let's see what happens. So you should be able to start the simulation here and pause the simulation at whatever points you want. And then you can see that we can turn the gravity on or off, or friction on and off in our example. And so that being said, let's just get started. So now I'm going to start the sim, and we'll see how the ball goes. So here you go. The ball goes up the slope, goes down, and stops. So here's the velocity time graph. You can see that the ball rolled up where the velocity or speed went down to 0, and then the speed increased on this side, and it hit eventually the wall, and the speed just suddenly dropped down as it bounced off, and the velocity or the speed again came back, and then it bounced and eventually lost all the speed and it stopped. So there you go. You can see how it happens. Now another cool thing is that it actually models gravity in this environment. So if we reset the simulation, the only way, unfortunately, to reset the simulation is you have to load this sim again. And so unfortunately I haven't really saved this in the right colors, so it kind of resets my colors as well. I'm going to set the color so it's easily visible. And now that I have restored this, now I'm going to turn off these forces so it's easier to see. Now if I start the simulation again, but this time I turn off gravity, you can see the ball is just going to float away into space, which is probably what you expect because there is no gravity to hold you down. So if I start this, you see that the ball is just gone at the same velocity. You see that 8.1 meters per second. It's just going. It's going forever, right? It's just like an astronaut or a rocket in space. It's just without a tether or gravity to hold you back. You'll just float away into space and the ball's just gone, right? So that's one cool thing that you can see here. If you turn the gravity back on and reload it, then you can see that. So if you load the scene again, and now we have to restore the color again. And so if you restore the color here, you can see that now if gravity is back here, then we should be able to run this again. And with gravity back, ball will come down and it will stall here again. So that's one cool thing. The other cool thing I want to show you is that as the ball rolls up, it actually just slides down because there's no friction. The ball doesn't really spin. It actually slides. And if we turn the friction on in this material, see right now the friction is 0. If we increase the friction to some value, right? And now if we run, let's just make the velocity of the ball again something like 8 as we had it. Oh, our simulation is still running. We can't do that. So there we go. Once the ball stops, let's stop the simulation. And now if we increase the velocity to 8 meters per second at an angle of 30 degrees, right? So let's make it 30 degrees. There we go. That's the velocity parallel to the slope. And that's let's reset our graph. And if we start now, and now we have our friction value set. Material has some friction here. So now you can see that the ball will actually spin. And so previously the ball just slid up the slope. Now if you run this, you can see that the line spinning here. This white line is actually spinning. So that's another cool thing to see, that the role of friction in your simulation is also pretty interesting to see. Now feel free to play with these things. The different surfaces you can change. You can add more surfaces. You can add plane surfaces. algodoo is pretty cool in that sense. It's modeling all the physical properties, the friction, the gravity, and you can add more balls. You can see the effect. You can create a billiards board and hit the balls with certain velocity, initial velocity, and you can see how the effects translate into motion and how the physics plays into your simulation. So with that, I'll stop here. If you liked it, give me a thumbs up and subscribe to my channel. And I'll see you in another video. Until then, take care and bye-bye.